All right, good morning, Rainy Math students. So today we are going to be going over lesson 6.1 to 6.3 review. So without further ado, let's get started. For number 1, it says solve the system of equations by graphing. I'm currently in here with my first period, and I told them that they need a ruler in order to do this. All right, for question number 1, solve the system of equations by graphing. So we have two equations here. They are both in y equals mx plus b. So what I like to do for these is I like to just write out m equals and then your b equals. The m is your slope. This one's going to be 2 over 1. And then your b is the number at the end, which in this case is a 2. For the other one, the slope is a negative 1/2. That's your m. And then your b is a negative 3. So for this one, very simple. We're just graphing. So for the top one, you start at 2. Here's 2. And then the slope is 2 over 1, so you go up 2 over 1. You only need 2 points to create a line. If you want to do more than 2, you are more than welcome to, but I'm going to just do 2. So there's your first line. The second one, you started at negative 3. And again, you always use your b. Just remember b, beginning, starting point. You start at negative 3, and then for this one, you go down 1 to the right 2, so it goes here. The straighter you make your lines, and the more you use your rulers, the easier it is to figure out where it hits. You'll notice that it hits here at this point. You'll notice that Mr. Rogers and I gave you a place to put in your answer. You got to put in your x first, followed by your y. That's called a coordinate point. So your answer for this one would be negative 2, negative 2. All right, so for question number 2, it says solve the system of equations by graphing. You'll notice that it gives you an x and a y. These are not in slope-intercept form because remember, for these, you're not going to have diagonal lines. You're going to have vertical and horizontal lines. So for the first one where it says x equals negative 1, you locate negative 1 on the x-axis, which happens to be right here. And anytime we're talking about the x-axis, it's got to go through the x-axis, which means it has to be a horizontal line through the negative 1. For the second one, it says y equals 2, so you locate 2 on the y-axis, which is right here. And just remember the y-axis is like a horizon, like the sun coming up and down on the horizon, so that gives you a horizontal line. Looks like that. And then once again, just like the first one, you figure out where they intersect. They intersect there. And that point where it intersects, let me change my color to azul, is negative 1 and 2. So negative 1 and 2. All right, so moving on to number 3. Again, we are still graphing on this front portion. Notice here, number 3, we gave you guys a line that's already in y equals, oops, give me a second, having technical difficulties. Nope, not that one. Yep, that one. All right, zoom out, zoom out. All right, so if I scroll down here to number 3, here we go. So for number 3, you'll notice that the first one is already in y equals mx plus b form. So for number 3, the first part, we just have to say what's the m, what's the b. So the m is a negative 3. Reminder that m has to have a rise and a run. So it's negative 3 over 1. And then your b is your 3. If you notice for number 3, what do we have in front of the y that shouldn't be there first period? A 4, which means that we have to divide everything by 4. Why divide by 4? To get rid of the 4 in the front, because a number next to a variable means multiplication, so the opposite of multiplying is to divide. So this now becomes y equals negative 3x plus 3. So if you notice, Some of you guys are like, oh, it's the same exact line as the one right above it, because the m is a -3/1, and then your b is a 3. So when I graph this, I only need to graph one. Why? Because they're both the same exact line. So I start at 3, and then I go down 3 to the right 1, which is right here. Oops, I didn't connect. No. There we go, much better. So that means that we have the same exact line. When you have the same exact line, it means that it is infinite solution. It has an infinite solution because you have the same exact line. For number 4, luckily both of these are already in y equals mx plus b form. The m is a 3/2. The b is a -1. For the bottom one, the m is a 3/2. The b equals 2. So when I graph this, I'll start by graphing the top one. We start at -1 because that's the b, that's the starting point. And then we go up 1, 2, 3/2. And when I graph, it looks like that. And then I go to my second equation. My second equation is m equals 3/2. My b is 2. Here's my starting point. And then from here, I also go up 3/2. And then what you're going to find here is that these give you two lines that never ever intersect, which are called parallel lines. And when you have parallel lines, you have a no solution. Alright, for the backside, they want to know, does the system of equations have no solution, one solution, or infinitely many solutions? So all you need to do for the next few questions, you have to figure out what the m is. So for this one, the m is 5/1. The b is -6. The m is also 5/1. And the b is, well, wait, there is no b. So as Marco Guevara has just said, the b happens to be 0. Okay? So for this one, you don't need to do anything other than look at the m's and look at the b's and try to figure out what the heck is going on. So what do you guys notice about the m's? They're the same. The starting point is different, but the slopes are the same. So whenever you have the same slopes but different starting point, that means that they make parallel lines, which means that there is no solution. So you don't need to do anything other than figure out the m's, figure out the b's, and then figure out if there is one solution, no solution, or infinite solutions. For number 6, same exact thing. The m is 1/2. The b is 8. The m is a -1 because there's an imaginary 1 in front of that x. Remember to also put a 1 underneath because there is an imaginary 1 underneath. And then your b is a -8. Okay? If you look at the m's and you look at the b's, there's nothing in common. The m's are not the same, the b's are not the same. So that means that these are going to intersect. When they intersect, it means it has one solution. For number 7, we try to make this a little hard. You'll notice that the first one is not in y equals mx plus b point or form. You have to divide by 6, divide by 6. You end up with y equals 4x. And then remember that there is a plus 0 at the end. So here the m is a 4/1. The b is a 0. Okay? And then if you notice the bottom one says y equals 4x. Again, you can add a plus 0 to it. So for this one, the m is a 4/1. The b is a 0. And what does it mean when you have the same m and you have the same b? Infinite, because it's the same darn line. Okay, whenever it's the same line, it has the same m, the same b, that means that it is infinite solution. For numero 8, we have y equals 3. There is no m. Okay, the m doesn't exist. Okay. And then for the b is a 3. So there is no m. The b, there's a 3. For the bottom one, the m equals 1 over 1. The b equals a negative 2. Okay? So if we were to graph this, we're not going to, but if we were to graph this, it would intersect because you have two lines that essentially end up intersecting. So in this case, you have a one solution answer. You have a one solution answer here. All right, and for the last set of problems, we are going to do what we've been doing this week, which is using substitution. So for this one, easy way to do these, box, circle. Box and circle. So when we look at the second equation, instead of rewriting y, there's our box, we are simply going to replace it with the 4x plus 10. And we're going to set that equal to the negative 2x minus 2. So for this one, we're going to need to solve. Okay? You'll notice in this problem that the only thing that's given is an x. So we need to solve for x. So on the left-hand side, you have 4x's. On the right-hand side, you have negative 2x's. It doesn't matter which side you put the x's on. I try to get rid of the negatives, so I'm going to try to get rid of the negatives here. Okay? So for the x's, the opposite of subtracting 2x would be to add 2x. Whatever you do to one side, you must do to the other. When you do that, these go away. You're only left with the negative 2 on the right side. On the left side, you still have a 6x and a 10. Because we are trying to solve for the 6x over here, we are going to get rid of the 10. So subtract 10, whatever you do to one side, you must do to the other. You end up with 6x equals negative 12. Divide by 6, you get x equals negative 2. Once you have found what the value of x is, you also have to figure out the value of the y. So then you come back here to your original two equations that I'm putting in purple. You choose either one. It doesn't matter which one. You choose. Michelle, which one do you want to do? The first one or the second one? The first one. Fantastic. The first one. So the first one says y equals 4x plus 10. Since we already know that x is a negative 2, all we're going to do is we're going to replace the x with the negative 2 and then solve. 4 times negative 2 is a negative 8. A negative 8 plus a 10 gives you a 2. Now that we have the x and the y value, remember that your final thing to do is to put it in a coordinate point. So your answer for this one is simply negative 2 and 2. All right, for number 10, again, we are solving by substitution. Here is my box. Here's what I'm going to replace it with. So I simply rewrite the bottom equation, 8x minus 2. But instead of y, I plug in what I know, which in this case is the 4x plus 1. And I set it equal to 13. Okay? Step 1, please excuse my dear Aunt Sally. So get rid of the parentheses. Notice that there is a negative 2 out here, which means you need to distribute a negative 2 to everything on the inside. This gives you a negative 8x. This gives you a negative 2. We didn't do anything to the 13. We didn't do anything to the 8x in the front. So we just bring it straight down. Okay? If you notice on the left-hand side, there's things that we can combine. We can combine the x's. So the question is, what is 8x take away 8x? That gives you 0. They go away, so you're left with a -2 and a 13. So then, if you don't have any variables, then you ask yourself the question, is -2 equal to 13? Well, no. No, it's not. So that means that this one has a no solution. Okay? For number 11, once again, we are solving by substitution. So let me scroll down just a tad bit so that way I have a little more space. So for this one, again, you are going to square off the one that is either y equals or x equals. Circle. You rewrite the other equation, which in this case happens to be 3x plus. But instead of the y, here's what you're going to replace with the -3x plus 10. And then you set this equal to 10 because that's what the equation tells you to do. So on the left-hand side, we combine like terms. If you do 3x plus -3x, well, those are opposite. So once again, these will give you a 0. We do not write 0x. So we are left with 10 equals to 10. Because the left side is equal to the right side, that means that this one is called a infinite solution.